of the trainings that is going to be coming up in May, basically next month, 29th to 31st. We had a very successful malaria microscopy training, which has been going on for quite an extensive time period. There has been a lot of questions when we'll be having the next malaria microscopy training, and I'd like to touch on that because I'm very sure it will be one of the questions that will be asked. The malaria microscopy training built up from the EQA programs that we've been having, and we ended up training our personnel to become WHO level 1 microscopists. And we have been able to go into CMEs for participating laboratories. So I would ask that if you are interested in having sorry. I'm sorry. Can you hear me? Can anyone hear me?
Yes.
Oh,
yes,
great.
we can hear you.
Thank you, Patrick. So I'll just keep going. I'm getting some waves that I can't be heard, but thank you for that, Patrick. So in way of malaria microscopy, I would ask if anyone needs a CME, a virtual CME. For the meantime, we can just hold a virtual CME for anyone who requests. I think next week, Wednesday, right? Yes, next week, Wednesday, we'll be having a series for the same. So as well, if there's any team that requires any CME in way of malaria microscopy, I know that question will probably shoot up in the, thank you, Lilia. Thank you for confirming that I can be heard. In way of the same, kindly go ahead and ask. Right, so the remainder of the calendar that we'll be having the rest of the year looks like this. We have method validation and verification and certainty of measurement. That I mentioned that is coming up in May, and peripheral blood film towards August, just before the conference. The conference will be, as I mentioned, in September. And then ISO 15189 2022. I think there has been a number of really interesting sessions around the new guideline, the new standard, and the changes that are currently there. Here in HuQAS, we as well have been going through it with a fine-tooth comb, trying to identify and see all of the changes and what those changes mean for us as an EQA provider in way of the clauses that are mentioned there, and as well in IQC. It's really interesting, and I ask that if you have not been able to step into any session, kindly have one. We'll try share out our own views on the new standards and the new clauses that have been mentioned. But I think so far so good in terms of the new standard. It really brings out quite a number of aspects that were either in gray areas, and it also does away with a lot of areas that were also in gray areas in the past standard. So I will not dwell on that. We do have CPD trainings on site in facilities upon request. So we do have quite a range of programs that can be requested for GCLP, a method validation, malaria microscopy, and the rest as listed down there. I want to now jump into the meat of this entire session. I wanted to give an overview of who HuQAS is for those who are participating with us for the first time. Welcome Aplonina from Jasper, Tanzania. I want to dive into the new reports that we currently have that we are currently looking at, and the reasons why we decided to have a bit of a change. One key thing is to try align ourselves with your needs from the medical lab perspective. There has been a lot of requests for Z-score over time so that you can be able to identify any bias that may occur in one test event to the other. There has been a lot of requests for a comparison of your specific method with other methods and other equipments. And as well, there has been a lot of requests for more smaller sized reports, so that you don't have to print out a huge report that goes over 30 pages or more. So taking into account all of the requests that we've been getting over time, and as well taking into account the requested aspects under 15189 ISO, ISO 13528 for proficiency testing, taking into account accuracy and precision ISO, and as well our own standard ISO 17043. All of these went into crafting the new reports. So I would really like to jump into this with you guys. So I'll take you through the first session, and then a smaller session will be taken on by Nancy Waithera, our quality and technical officer, and then finally will be taken through the last sprint by our quality and technical manager, Paul Kahara. So great. Let me just share with you this screen. This screen is the first page of all of our reports. All of our reports will now be having a front page that indicates clearly to you the specific EQA report, whether it's an interim or a final report or an amended report. So by guideline of 17043, we have those 3 key reports: an interim report, in which case you as a lab get it before you get the final report, you review it. And then after a couple of days or immediately after, you get a final report. Now, depending on when and how many revisions or requests have been given to HuQAS, we review them before we churn out the final report. So it's very important for us, once we get the report, check if it's an interim or a final report before you print it out, so that you can be able to have the final or most conclusive report that you can get. An amended report comes in when you have any revisions or requests that have gone through our HuQAS advisory board, and then from there you do get an amended report on your report. So it's really good to understand that. HuQAS is very open in engagement. We've for quite a long time now been able to streamline some of those processes internally. So once you give us a request of review, we always go through our motions and processes in terms of getting things ready for you. Outside of that, you have a very unique report identification number. Now, this is important not just for HuQAS, but as well for you, to make sure that you don't have 2 reports that are filed that are different. So again, this is quite important in terms of documentation. Of course, in very bold colors, you have there your laboratory name and your unique laboratory code, which is referenced in every page there hereafter, and as well the program name. Well, the program name is good to expound a little bit, and I thought this would be a great opportunity to have this conversation. H in the program code denotes HuQAS. At the 3 or the 12 in number, there goes for the number of cycles. The 5 or the 1, when you're having a monthly EQA, denotes the number of events in the year. The number of samples, sorry, the number of samples in the year. So the number of samples that you'll get in a specific event. So if in the monthly, you'll get 1 sample every month, in the quarterly, you'll get 5 samples every month. And the BCHE denotes the specific program, basic chemistry. So if you are to look at special chemistry, you'll probably have 3 cycles, 5 cycles, 3 cycles and then 5 samples. If you're looking at HB1C, you have, I think, 2 samples, 3 cycles. Coagulation, you have 3 cycles, 3 samples. So that variation gives you that type of motion. The thinking around this goes into quite a number of estimations, which I'll not jump into right now. Of course, there's a report date as mandated by ISO 17043 to give you a report date when that report was issued. And then finally, there's this comment down here, and I'd want to take some bit of note on it. This is a shell in the ISO 17043, where we have to tell you what we have subcontracted, right? So HuQAS, for many years, we have had a majority of our processes solely manned by HuQAS members. We believe firmly in building the African market in way of science. So majority of the productions and everything else happens in HuQAS. The key aspect that we a subcontract is courier services. And that ends for that first page. So the second page, you would be looking at a table of contents. Now, this was not there previously. This was not there previously, and the need for a table of contents that is clickable, because you will be able to click on a specific aspect of every section of the report. And if you click on each of them, they will take you directly to where you need to be, if whether we want to click on a specific analyte, it will take you directly to that specific analyte. And that aspect we felt was very important, so that we will be able to now navigate more easily on your extensive report. The expert commentary used to be all the way at the back of the report. We're bringing it in the first 3 pages. And there's some few things that I'd like to highlight here. I think there has been a lot of conversations around what is this expert commentary and why is it important. This is mandated again from our ISO 17043. To give from our advisory board and the technical team as well, indications of why it is important to have an expert commentary and which details go into it. The first one is the overall performance, and I'll just skim through all of this because not all of them will appear in every single report, but we try as much as possible to have majority of them. Overall performance, basically against prior expectations. So in the previous reports, what it was like, in terms of measurement uncertainties, in terms of your CVs, what that performance was, and looking at this current report, what it was like. So we do all of this into consideration before we give a recommendation of a score. Variation within and between participants and comparison with any previous PT rounds, similar PT testing schemes, or published precision data, variations between methods or procedures. So we do comments on all of these. If not published, we do have comments on all of these internally. Possible sources of errors. Of course, we have in every single report possible sources of errors. And we do document majority of these, and as well educational feedback for participants to be able to look at their reports and tell them, so they can be able to guide themselves on where they need to improve, either by way of education or whether there's any continual improvement that has been identified. As well, unusual factors that make the evaluation report impossible to grade. So we've had we have situations where the report is not able to be graded. This is allowed by ISO 17043, and I'm glad the ISO 15189 kind of denotes or shows cause in this direction for the current standard. And then in the 2 last clauses, F and G, any other suggestions or recommendations that we may give, and other general comments. So kindly take the expert commentary to heart. It gives an overview of all of your participants for that specific analyte. But in cases where the lab is denoted specifically, we usually highlight your laboratory code so that your data stays confidential. Right. So up until that point, the report is entirely similar. The only difference that you'll find hereafter will either be qualitative or quantitative programs and semi-quantitative programs. And the very first new change for these programs, specifically the chemistry, special chemistry, hematology, coagulation, CD4 tumor markers, ESR, hepatitis B, and HIV, because these use more values than anything else. So from here onwards, you'll find that the report will be a little bit different. So let's see what's different. So this is a report summary section. Now the report summary section outlines basically in a one-page summary every single analyte in way of performance. You have a grade, you have a Z-score, you have a CV, you have a standard error, which is the uncertainty, the standard deviation, the mean, and the statistical count, all in one page. And the aspect of the thinking here is, up until this point, you should be able to print your report from page 1, page 2, page 3. You can't be able to print out this report and then move by looking at key areas that you would require. So what are we looking at here? There's an indication of your laboratory code, your test event, along with the status of the report, whether it's interim, I think we went through this, final or amended, and the program name and a unique report identification number. Now, again, on this same report, you can be able to look at your overall score, which is an aggregation of each analyte score. So we usually give a score for every single analyte. So for bilirubin, you have a specific score, which is 100. All of the analytes that you might have participated in, this gives you that overall score. Now, this was not there previously. Why? Because in most cases, you do find our lab technologists going back and getting an average score of the entire report so that they can be able to say whether they met their own internal expectations or not. So I guess this was as well gotten from you, our participants, and we went out to have this so that you can be able to get a better grasp of the entire report as you go. On this same page, we do have a highlight of the specific grade for each analyte performed in the test event. So whether it's acceptable, not acceptable, or warning. All of these will be explained in depth as to how we arrive at it, but hint, it's linked to your Z-score and SD. The score as well at this point for every single analyte. So you can be able to tell from this one pager that, hey, these are the key areas that I need to go to from the rest of the report. And these are the key areas that I need to have a review of. I don't need to go through all of the analytes or all of the rest of the report. I already know where my problems are. And you can be able to use the table of contents to easily click and take you to that specific page. So in a sense, up to this point, you have 4 key pages that you can be able to print. Now, these 4 key pages, that's the cover page, the front page, the table of contents, the expert commentary, and the report summary, all give you the entire view of your report. Up to this point, you can be able to literally print it and file it without necessarily going into all of the details. But if you wanted to go to all of the details, we'll go into that in the next slide. But for now, I want to give myself a break and give my colleague the chance to speak to us about the specific areas of performance evaluation in way of telling us how we arrive at our consensus values. How do we come about with this mean and SD, and why is it important to have a Z-score, and why do we depend on the Z-score for grading? So I want to welcome Nancy to give us a word or two in this direction so that we can move on with the rest of the report. So Nancy.
Hello, everyone. Thank you very much for being here today. My name is Nancy Trege. As some of you I'm seeing several familiar faces and names here in the participants box. So I'm going to take us through the performance evaluation criteria. And basically, this is explaining how we evaluate your performance in EQA. And I'll focus more on the Z-score and the interpretation, and basically what all those statistics mean so that you can be able to interpret your report better. So first things first, as you may know, the reason we participate in EQA is to evaluate or compare your performance with that of your peers. So now that you're talking about the quantitative reports, that's where most of the bulk of this statistical things come in. I want us to focus on that first, because when it comes to qualitative, there isn't much when it comes to evaluation, because it is either you are within the range, you are within what you accept, or outside what you expect. So in terms of quantitative reports, we have three ways. And the question we are asking ourselves here is, where is the target value coming from? How does the EQA provider decide or settle on this is the mean and this is the standard deviation for this particular value, and these participants who got this value passed and these ones failed? The first way, or one of the ways we come up with this target value or assigned value or expected value, is by getting a consensus of the values from participants. So we collect all the results from people doing the same task on the same analyte, and then you group them together in peers and come up with a consensus. As you may know or you may understand, this word consensus is finding a level of agreement between within different data points. So when you group these people, we collect all this data, we can pair it in three different ways. And by pairing, I mean putting values or participants with similar characteristics together. And because we are talking data and science and everything, we have three main ways we can do this pairing. And the first one is by method. So this method pairing basically means collecting people who have used the same method and putting them in the same peer group. So you put them in one basket. And within this basket, you check their results or their data points, and you look for the level of agreement. You check how the relationship between these values or these results that they submitted. And to do that, we calculate a mean and a standard deviation and some other values we will see later. So this method pairing is one of it. For example, if something like total protein, you have different methods, and one of the most common one is biorate. So you group people who used biorate together and people who used a different method together. So at the end of the day, you may end up coming up with 5 or 4 or 2 different peer groups based on the different methods that were used. Also, we can group or peer based on instruments. This is where we place people using the same or similar instruments together. For example, if it's hematology, 5-part analyzers, we can group HuMaCount 5D together, Mindray together, Sysmex together, and the rest. Same to all these other analyzers that are in use. So basically looking for people with similar characteristics and putting them in the same peer group and calculating a mean and a standard deviation from their values. We can also use all method pairing. All method pairing is where we now put everybody, regardless of the instrument or the method, we put them in the same peer group, and you calculate a mean and a standard deviation. So looking at this, all these different scenarios, at the end of the day, you come up with a mean and a standard deviation. And I'm sure if you've checked your results or your reports, you normally see that table that tells you the mean and the standard deviation of the peer group that you are put in. So there is a threshold for doing this method, for doing this kind of evaluation, and normally it is 5 participants or above. So we can only do consensus when we have data points or results from 5 participants or above. So what happens when we have less than 5 participants? That means maybe there's an analyte that maybe 2 or just 1 person or 3 people entered results for. So we go to our next method of coming up with our fallback method, which is getting consensus values from reference or expert laboratories. So now this is where, if the consensus limit has not been reached, that is, the participants are not 5 or above, we resort to taking this sample and analyzing it in expert labs or reference laboratories that we have pre-qualified according to our ISO 17043. and they analyze the samples and they give us results. Then you look at these results, come up with a mean and a standard deviation. So at the end of the day, we still get what we were looking for in the first instance. When that is not possible, or when we cannot go by that, we cannot use that that method, we can also use assigned values if we used a certified reference materials. So this is where, if the material was a certified reference material, we resort or we use participants provided values. So these samples, when you get them, they normally have an insert from wherever we source them. They have an insert that says this sample has, if it is ALT, it is 20 or 50 or whatever it is that has been provided. So we can choose to use that information and evaluate your performance based on that, that provision. So these are the three ways where we come up, how we come up with the target value. Again, it is informed and guided by two standards that we use, 17043 and ISO 13528. So we have a logic when we of when method pairing is done, when instrument pairing is done, when different laboratories are used, and when manufacturers provided values are used. So at this point, at the end of the day, you have a mean and a standard deviation. But now, remember, in this peer group, we need now to take each lab, which in this case, consider it's yourself. We need to take you and check whether you are acceptable or not acceptable. So for us to do that, we have to calculate a statistical value we call a Z-score. And this Z-score is one of the most important statistical parameters you will see here. The mean and the standard deviation we calculated from values from the peer group. We also look for the coefficient of variation in that data, the data points in that peer group, which is showing us our, the variation of these results, like precision. So there are limits to when we can do this pairing, and these are informed by this the variation, coefficient of variation, as well as the standard error. And in this case, you'll see the standard error in your report written as SE. It basically means it's the uncertainty of measurement of the assigned value that we've given you. It is the level of doubt that we have as a PT provider that is the actual mean that we're using to evaluate you. So the last two statistical parameters you can see here are just for your information purposes. It's just for you to know, and it is good for you to know how to utilize them and all that. But what I want us to focus on is on the first three, the standard deviation, the mean, and the Z-score, because that is what directly relates to your data. Now, what is this Z-score we keep talking about? And by definition, Z-score is also called a standard deviation index. It basically means the number of standard deviations your data or your results is away from the mean. So it is, sometimes we keep saying when you're evaluating your IQC, the acceptable limit is mean plus or minus 2 standard deviation. So why do you think we always say 2, or what is this 2? So this 2 is actually a Z-score that has been acceptable somewhere. So this Z-score that you'll be seeing in your report, or the standard deviation index, is basically telling you how deviated or how many standard deviations your result is from the mean. And that means the bigger the Z-score, the worse your performance is. That it basically says the more your Z-score, the more deviated you are. That means you are outside. Your performance is very, very different from everybody else. And remember, we're doing EQA to look at compare our performance with the rest, our peers. And we shouldn't be that deviated in an ideal situation. Because if it's a patient, it's the same patient who comes to your lab, it's the same patient who goes to the second lab. So your results, or the results you give this patient, should be relatable. That's why we check at your level of deviation to tell you how badly or how good you're performing. And that's why we call that value Z-score. And it has been proved and known to be the best criteria to review your performance acceptability. Now, to calculate the Z-score, remember, previously we have said that when we get the peer group, we calculate a mean and a standard deviation. So for us to calculate this Z-score, I'll just need these two values, the mean and the standard deviation for that particular analyte and that particular sample. So I will take your results. That's why you have this formula here for calculating the Z-score. I'll take your results. I minus the mean and divide by the standard deviation. So that is how we come up, this Z-score is calculated. And it is important for you to know this process of calculation, not necessarily cramming the formula, because the formula is available on the internet and there are tools to do that. But for you to understand when you need to repeat testing and to re-evaluate yourself when you're doing root cause analysis. So to recalculate the Z-score, you just take that result, you minus the mean that is provided in the report, and divide by the standard deviation. But now, what does this Z-score mean, or how do you interpret it? How do you know whether you have passed or you failed or you get a warning? So there's an acceptability criteria. And it says that if a Z-score is between 0 and 2, that is acceptable. And that is why, by the way, in most cases, we normally say it is mean plus or minus 2 standard deviations, because that standard deviation is like the acceptable Z-score. So 0 to 2 is acceptable Z-score. But once you start going beyond 2, that means you start deviating more than your peers. So when you're between 2 and 3, it means it's a warning. You're not performing very well, but you're not that badly either. So it just tells you that there could be an emerging problem in a system that if you do not fix it, you will be deviated and you'll be performing differently than everybody else who is doing that test. That means if a patient is coming to your lab and they go to another lab, they may be giving them significantly different results, which shouldn't be the case. So a warning signal, some labs choose to treat it as a, as a potential nonconformity. Others choose to treat it as a nonconformity. That is up to you to decide. But it just means you need to act on that thing and prevent it from becoming a not acceptable next time. And this not acceptable happens when this Z-score goes beyond 3. Beyond 3, that means now you are three standard deviations away from the mean. That means you're very like you're becoming more and more deviated from the mean, which is where we should all be. Ideally, in a very ideal situation, we should have a Z-score of 0, because a Z-score of 0 means you're hitting the mean. You're literally getting what the average of everybody else is getting. And this, a Z-score greater than 3 means that you are not performing very well. It is unacceptable, or what you call an action signal, and it means that you should do something immediately, because that problem is also affecting your patient's results. So whenever you get unacceptable results, not acceptable results, it means there's a problem that happened when you're analyzing that EQA sample. And whether that problem is random or systematic, as we will see later, it could also be happening for your patient samples. So you please stop and you check your system and you find the problem, fix it. Then you come back, you repeat the testing if you need to, recalculate your Z-score, and use this criteria to reevaluate yourself to check whether now you're acceptable or not. But that process of root cause analysis, we will touch on it a little bit in the end. And yes, that is it. That is what I wanted us to understand about the Z-score. And I hope you got something, and you know what it means and how to utilize it in your reports. And that is specific for quantitative reports. Qualitative reports do not have Z-scores because we don't look for consensus or for peering. You're either positive or negative, or as we will see later.
Here we go. So from where Nancy left us, she left us in a space where we were looking at how the report looks like in the first 4 pages. And we mentioned that in those first 4 pages, you can now be able to just go ahead and print those first 4 pages, and you should be good to go in way of a reference. And if you require more detailed analysis of your report, then that's where we look at a per analyte performance. Now we've enhanced this per analyte performance to have some bit more elaboration in way of how you have performed in comparison to your results and other methods. And this is important. Why? Because let's say your neighbor or your equipment that's currently there is performing a little bit better, your secondary equipment. How will you be able to visually look at those two peers and clearly make a decision off of it? In this specific report that we are looking at, we have a section A that highlights to us the lab code, the program code. We looked at all of this, a unique report number and a program ID that is incorporated in your report number. So this will repeat in all of the specific pages so that you do not get lost. Which report was I looking at? Or when you print it out, it also gives you direction into which test event you are looking at. If you look at B, there's a score. There's a score, the same score that we had in the page 3 that had the performance report summary is repeated here. This is how you performed on the specific samples, right? As well, you can look at your specific analyte in your units of entry. So we give you back the reports based on your units of entry. Remember, albumin may probably have GPAL, GPADL, and other labs that are operating at different units. So we give you back your results in your specific units, which is important for any PT provider. And as well, just below that is a bar that highlights to you the instrument that you used for your specific report, the method that you use for that specific report, and that's important. Why? Because of root cause analysis. If you went at this wrong method in that specific event, then you need to go back and change that because possibly you appeared wrongly, right? And then as well, how you appeared. So in this case, this lab was paired by the specific method. Right below that table is a description of, let me just go to it. Here we go. Is a description of your results, your the number of statistical count or number of participants for that specific analyte, the mean, which is basically the robust mean that, or the robust average that Nancy just mentioned about, and the standard deviation for proficiency testing calculated from all of the participants' results, right? All of these 3 key areas, 4 key areas go out to give you a view of how what your data was coming in and how it was specific. You can specifically look at from how far you are in the mean and how your SD looks like. And then the standard error. Nancy mentioned it as the uncertainty of how if the specific analyte is in way of the PT provider's analysis. If it's high, of course, it's always a problem, but if it's low as 0.3, it's pretty okay. I have the calculation there in way of how you can go about calculating it yourself. But it's not necessary. I think one of our participants needs to be muted. Jennifer, let me just mute you. And then you have a CV. The CV.
Mr. Paul.
Kindly, why don't you wait or give us a chat in terms
Mr. Paul.
Kindly give us a chat in terms of your questions so that we can be able to proceed with the session. As well, if you're looking at the report and you're looking at the CV, you want to be able to pay attention to the CV. If as well as a high CV, you want to be able to critique that specific report and go about making sure that your report makes sense. The Z-score is what Nancy raised as how your bias is in terms of your report, whether it's acceptable, it's below or plus or minus 2, whether it's a warning, it's between plus or minus 2 and plus or minus 3. And if it's not acceptable, is anything above plus or minus 3. Finally, you can look at this specific new table, which goes out to highlight your peer grouping name, right? Now, what is unique about this is that it gives you other peer groups and how they performed, and you can be able to compare the robust mean, the standard deviation, the uncertainty for those specific peers with your specific peer, which is quite important in this specific scenario. Outside of this, we do have an enhanced Z-score over time. We used to have it for that specific test event, but now we have it to include your past performance so that you can be able to review how acceptable your results have been over time. Now, I'll not dive into the specifics because I think my colleague Nancy has gone into explaining how to look at the specific aspect. But if you were to look at the coloration, when you are on the white, you can and the white and the pink, I want to say, and then there's a deep pink at the top, right, and at the bottom. If your score is acceptable, it should be within the 0 to 2 mark, right? And if you are in a warning, it's from 2 to 3. And if you're above 3, you're from 3 and above, basically you're not acceptable. This is a very easy and clear way for you to be able to tell over time, and I guess this is what one of our participants was saying, that they have failed on 3 continuous events and they can visually see the trend over time, and they need to have some bit of corrective actions. And this is where you go through the motions of root cause analysis. Whether you need extra hand from the HuQAS team, we are ready to assist with that. So that shows specifically your Z-score for a specific test event. For monthly, it will show 12 points. For the quarterly, it will show a maximum of 5 events, so that you can be able to give guidance to your test. And then at the bottom is, of course, the number of test events. So very quickly, I want to look at this very colorful histogram. The overlapping histogram is a powerful histogram that shows a number of details. And the first one is the all method. Now, in a previous presentation, Nancy mentioned that you are peered by your all method, your method, or your instrument, or your analyzer specifically. This is given guidance 13528, clause 10.2. Now, how we go about this specific appearing will now visually be presented to you by way of plotting. So if your instrument peer is met, you will be shown by a purplish color on the specific plot, and your all method peer will have a reddish coloration on the plot, and as well the all method, you'll have a very pink color in it towards the end. Now, this is important because of a number of things. So if you're performing really well in your specific instrument and your method is not performing very well, you would like to show this in a plot so that you can be able to visually think through how to go about root causing. The histogram is created using every participant's result, and this is indicated by sticks, if I were to call it, or singular representation points at the x-axis. If you can look at the x-axis on my plot, there's little small sticks which represents everyone's result that was entered. So what happens when you have a kernel density curve or a normal distribution curve that is outlined just above this overlapping histogram as shown? It gives you an indication of where everyone lies, right? It gives you an indication of where the majority of the participants are, and that's why we decided to keep that specific plot, because you can see a small variation from your instrument curve to your method curve and the all method curve. Now, this is very important in way of where your result lies under 5.3 G per DL. I think this is a very good angling into how the analysis is done from the PT provider's side or the HuQAS side, so that you can actually tell that your result was placed here and you're acceptable, but then under your instrument, you can literally tell how precise or how accurate you were in terms of your result under peer, under each peer, under the instrument peer, under the method peer, under the all method peer. Right. So that's basically the quantitative reports. And now let's talk about the qualitative reports and possibly what fellow from Loganzilla was asking. Now the malaria reports are specifically here. And let's talk about that. These are the basically the qualitative reports that we have. The urines, the malarias, the throat cultures, the microbiologies, the rest. And I want to talk about how we go about assigning values. The value is again picked from the previous presentation. Is given from an indication of consensus values from expert laboratories or assigned values from reference materials. And of course, there's a consensus as well when it comes to those that are participating, right? Now, and this is allowed under ISO 17043 and ISO 13528. The expected results are usually either such as this: positive, negative, 2+, 3+, no MPS seen or MPS seen, Plasmodium ovale, or so on and so forth. Well, and the grading is usually very straightforward. It says that unacceptable to show that it's an agreed, that your result is an agreement with the assigned value or the target value, or disagreement by way of not acceptable, showing that it is not agreeable with everyone else in terms of a consensus or in terms of the assigned value from a reference material. So the report summary kind of looks a little bit different, and I wanted to highlight this. There's something that is called a certificate of analysis, and as well it appears in our quantitative reports. The certificate of analysis is basically the values that have been arrived at from expert laboratories or values that have been arrived at by certified reference materials. So in specific, your report summary, the first 4 pages that we talked about, will have a smaller number of tables that only highlight the COA or the acceptable response from the PT provider's perspective. Is the acceptable result is derived from these specific areas. Majority of the entire report, the report summary looks quite similar. And I'd like to, jump to the specific report in terms of performance. Of course, malaria is one of our most uptaken program, and I'd like to highlight this. This looks similar for majority of them. Urine looks pretty much the same outside of the quantification part. So under A, you do have your score for that specific analyte. Just underneath that specific analyte, you do have the instrument or model that you use. This is usually manual in our specific case. And the method, whether it changes or not, is as well manual. Just beneath that is your sample, a tabulation of your sample, the statistical number or those that participated in this specific parameter. The response, whether Plasmodium falciparum, whether P. ovale, and of course the COA or the acceptable responses from the PT provider or HuQAS's perspective. And finally, a grade. Now the grade again is given based on the acceptable, the COA, or the specific response that's given from the participant. Just underneath that, we have combined this specific report to have both qualitative and quantitative aspect so that it can be easy enough for the lab to interpret in one full sweep. So A was PF, and that's why they do have the chance to be able to give quantification. So under the quantification, it was not acceptable because under acceptable, the ranges were from 257 with a mean of 343 and an upper limit of 429. And their result was 850. So it was way above what the acceptable scores were. As well, under C, if you can look at the same, they gave the same response of PF, which was acceptable, great. And then under the score, they gave a quantification of 93,200. And when you look at the specific acceptable range, which ranges from 609.38, and the target value being 81,250, and the higher upper limit at 101,563. I hope this makes interpretation a lot easier because you had this in 2 separate pages in our previous reports. And then finally, of course, there is always a sense to give you a sense of how the data was populated or looked like. And in this specific scenario, we do have malaria microscopy identification plotted all in one plot. So you have sample A indicated here. Just highlight this, indicated. Okay, great. Indicated here, and sample B indicated there, and sample C indicated there, so that all of the analyte performance is indicated in one specific plot. Now this gives a reduction on the number of pages for the qualitative reports, the qualitative and semi-qualitative reports. And this went out to make sure that the successes of making your life easier in terms of interpretation of acceptability for your reports, and making your life easier to make sure that the report is able to give you a more extensive elaboration of how to go about interpreting your acceptability or not acceptability question.
So my name is Paul Kahara, and I want to take you briefly through a root cause analysis session for EQA reports. I know this is what worries or bothers most of us in our facilities, especially when we receive reports that are not acceptable or that have exceeded the acceptability criteria in terms of the international standards and even our EQA procedures back in the laboratories. Now, borrowing from ISO 15189, the current version of the standard, it anticipates that there will be some times when we receive reports that are not satisfactory. And it goes on to tell us that EQA reports or data shall be reviewed at regular intervals with specified criteria. Now, these you do either using the criteria of the HuQAS EQA, or either the criteria given in your own SOPs. But now on comment number H, or the requirement number H, that where EQA results fall outside specified acceptability criteria, what are we supposed to do? So the standard tells us that we must initiate appropriate actions, or the appropriate action shall be taken, including assessment of whether the non-conformance is clinically significant as it relates to patient samples. So what I want us to agree from this point is that the acceptability criteria can either be derived from the EQA provider or the PT provider, or you can have your own criteria within the facility. But what matters is that you must review the reports and initiate appropriate actions whenever you have failures. So when you receive a report such as this is an example of a chemistry report with 3 parameters, like explained before, where you have 3 parameters. You have bilirubin, both total and direct, and then you have calcium that has only passed 1 sample. you notice that only sample A had a Z-score of 1.7. I hope we can remember that any Z-score that is between -2 and +2 is treated as acceptable, while any Z-score that lies between 2 and 3 on either side of the mean is treated as a warning, while a Z-score that exceeds 3SD is treated as a not acceptable report. So what I want us to address is the not acceptable and the warnings. Again, from a question asked in the chat on the chat box, for warnings, for us, we give a score of 0 for such a grading. But back in your laboratories, you may borrow the same Westgard rules that we use in the for IQC, where we mentioned that if you are running, let's say 2 or 3 IQC levels, and one of them falls between 2 and 3, while the rest are passing, then you just treat that as a warning, probably just to look at it so that next time it does not fall beyond the ranges. But if it falls beyond 3SD, that's what we call the 1-3S in the world of IQC. And in our EQA scheme, that is graded as not acceptable. Again, you have to initiate some corrective actions towards it. So what is a root cause analysis, or what is a root cause? We have some information, probably in other sessions, that a root cause is a principal cause of a problem. And in this case, the principal cause of why an EQA failed. So the process of root cause analysis is determining or establishing that principal cause so that we can deter or prevent any recurrence of such failures. We all know that whenever you see a report failing, you receive a report that is unacceptable from the EQA provider. Those are just symptoms, but the actual problem will have to be established through a thorough root cause analysis. Statistics show that 81% of all EQA failures are attributable to the lab, while 15% of all failures of EQA are attributable to the PT provider, while 4% of the failures indicate some combined reasons why it failed between the EQA provider and the laboratories. This is a study done in 2017 in Norway. Now, out of the failures that you have for EQA, I want to put a surprise here that surprisingly, 72% of all those errors are actually transcription errors, either through wrong entry, interchange of units and such. While 24 errors will cover all the other, so all the other issues, systematic, EQA, calibration, curve deteriorations, reagent expiry, or reagent contamination and such. While 4%, you may not be able to establish the real cause, and so you have to keep monitoring the tests, either through EQA or through IQC. Just to highlight or to outline some of the random errors that causes EQA failure. Of course, one of them is insufficient mixing of the samples, a very common problem when it comes to the cause of EQA failure. Issues to do with pipetting, either the technique or failure to calibrate pipettes really causes an issue when it comes to EQA failures. The sample mix-ups, dilution issues, result unit conversion issues, either you never did a conversion or such, contamination of the reagents or carryover in some of our instruments, or sometimes mislabeling of the materials. When it comes to systematic errors, these are errors that are either attributable to the reagents or the analyzers themselves. And like we learned in the other presentation, they account for about 24% of all the errors that causes EQA failure. Now, when it comes to root cause analysis, because this is just an overview, I want to share some tips on how you can carry out a root cause analysis that is effective, that will help you to initiate preventive or corrective actions that are effective. So number one, you have to assign this responsibility to a staff who is trained and competent on root cause analysis. So before giving that report that has failed, for a staff to probably troubleshoot why it failed, it is good to consider a session, a CME within the facility on harmonizing our procedure or our approach in terms of root cause analysis within the facility. So we recommend that you have a session on RCA and probably have the competent people introduced to root cause analysis for effectiveness of the activity. Now, the other issue is recording of all failures or of all unacceptable results on a corrective and preventive action forms. I know that we have facilities with different corrective action forms from preventive action forms. Now, failure of EQA in most cases requires a corrective action form. So ensure that you record the problem so that in future, we can know exactly what happened and probably prevent that from ever happening again. Of course, we need to ensure that we don't jump into the conclusions because the problem or the failure of EQA is not always obvious. The solutions are not always obvious. So let us consider carrying out the root cause analysis procedure, probably through a brainstorming session with one or more staff, so that you're able to establish the real cause for the failure. Be aware of all the causal relationships for each nonconformity. I know most of us are using the fishbone diagram for investigation of the root causes, troubleshooting of the root causes. So let us know all the factors that can cause EQA failure, and
no.
Try to gather the principal cause. Then suggest improvements that are implementable, and also keep practicing the techniques of root cause analysis to sustain competence. So if you do a root cause analysis once, that may not assure you the competence that is required. So let's keep practicing this so that at the end of it all, we're able to have an effective root cause analysis practices within our facility. Now, some of the pitfalls or challenges to root cause analysis. One is not understanding the problem. I mean, not understanding the failure properly, and therefore introducing solutions that are not specific to the real problem. Not asking for help, and these usually advocate that whenever you receive an EQA report whose cause of failure you cannot be able to establish, always reach out to us in terms of either a phone call or an email. Let us try to troubleshoot together so that the corrective actions you are going to initiate are actually going to be effective and are going to deter any further failures in the future. Then when you're carrying out the root cause analysis, try to point out all the causal factors, all the possible failures, and then from all the failures, establish one that is actually the principal cause for that unacceptable performance. Let us avoid adopting the remove and replace mentality. Sometimes we give the EQA samples to one personnel who is probably not experienced as the others. And then when they fail, from there henceforth, we declare as a lab that they are not going to handle any EQA samples. So we always give to the competent personnel. So let's ensure that we train. Instead of saying you're not going to issue these samples to an incompetent staff, let us consider training everyone and ensuring that we don't adopt this mentality of removing and replacing, or removing an analyzer because it is failing, introducing a new one, and then you still have the same problems. Adopting a silver bullet theory where you feel that one solution or changing the reagents or the supplier is going to solve all the issues to do with EQA. And of course, jumping into conclusions is another pitfall or a challenge that is experienced by many facilities when it comes to root cause analysis. In my presentation, I mentioned a number of terms that I probably would want us to understand. Now, an unconformity, we all know, is any non-fulfillment of a requirement. Or in this forum, we can talk of unacceptable EQA report. We can handle that as an nonconformity. Now, a correction is any immediate action to eliminate that detected nonconformity or its immediate effects. So the failure to EQA, like you receive an EQA that has failed, probably for calcium, giving you a Z-score of -2.5 as a warning. So the first thing you want to do is probably to repeat or probably to recalculate the Z-score and confirm whether that was an actual failure or not. So any action to eliminate that nonconformity, to make that EQA pass again, would be a correction. Whereas the corrective action is any action taken to eliminate the root cause of a nonconformity that has already occurred to mitigate against recurrence. So if probably in your root cause analysis, you establish that the cause of that failure of EQA is inadequate staff training, then the corrective action in this case would actually be taken through all the staff involved in EQA analysis into a training. And that would be the corrective action, so that in the future, you don't end up with such failures when it comes to EQA. Whereas preventive action is any action taken to eliminate the root cause of a potential nonconformity to ensure it will never happen. So preventive action, this failure hasn't happened. Probably in your Z-scores, you note a Z-score of, let's say, 1.9. Now 1.9 is still acceptable in terms of the acceptability criteria for EQA, but you may want to ensure that in the next EQA round, you take your results back closer to the mean. So you initiate a preventive action, probably carrying out a calibration, a calibration exercise to ensure that no failure is got in the next EQA run. And so in an overview, that is what I wanted us to look at in terms of basic root cause analysis for EQA. This is just an overview. Probably we can have more engagements either on phone, on email, on how to properly do a corrective action or a root cause analysis for any EQA failures that you have experienced in your facility.